Hello everyone, welcome to my talk. I am Pinjia He from ETH Zurich. In this talk, I will present structure-invariant testing for machine translation. This work is performed with Clara Meister and Zhendong Su. Machine translation software such as Google Translate and Bing Microsoft Translator has been widely used in our daily lives. However, they can produce translation errors that lead to unpleasant experience and serious consequences. For example, one of the authors of this paper intended to bring his son to the local zoo in Zurich, and he go to the website, which is in German. So he asked for Google Translate to translate it into English. And the result is children up to the age of 15 are given free admission to the zoo on presentation of a valid ID. However, they were refused to enter the zoo because this translation is wrong. The correct translation should be children are given free admission to the zoo on their birthday on the presentation of a valid ID. Here is another example. A Palestinian man was arrested for posting just good morning on Facebook because his post was wrongly translated to attack them and hurt them. Thus, we know that this kind of translation error can lead to very serious consequences, and an automated testing technique for this kind of software is in highly demand. However, testing in this scenario is very challenging. One reason is that compared with simpler tasks such as image classification that has a fixed label, for machine translation, one source sentence could have multiple correct translations. To address this problem, in this paper, we propose structure-invariant testing, and the key concept of our framework is structural invariance. That is, translation results of similar source sentences should exhibit a similar sentence structure. For example, the two sentences on the left-hand side looks quite similar, only one word difference, and the third sentence also looks similar, and however, their translations are quite different. The first two translations are very similar, and the third translation has a quite different structure. And we observe that the translation of the third sentence is incorrect. Its meaning is, I live on campus and I am tall. Our structure invariant testing contains 4 steps, and I will introduce them one by one. First, generate similar sentences. Given a sentence, we will replace one word in the sentence with similar and suitable words. For example, we will replace smart by cute and tall and etc. In our implementation, we will replace the adjectives and nouns in the sentences. To find a suitable word, we use an NLP model called Mask Language Model. The second step, collect target sentences. In this step, we input all the source sentences to any kind of machine translation software we want to test and collect the translation results. Third, we generate the representations of sentence structures. For each translation, we generate a structure representation. We consider 3 kinds of structures: raw sentence, constituency structure, and dependency structure. We introduce dependency structure here. For a given sentence, the dependency structure looks like a tree, and this tree captures the relations between different words in this sentence. For example, system and machine is one pair called compound because they can form a compound word. The fourth step is error detection. We form the structure of original sentence translation and the structure of any other translation structure and calculate their distance. After calculating all the distance, we rank the pairs according to their distance. The pair with the largest distance will be returned as the top one suspicious issue. Each issue here contains source sentence, the target, the similar sentence, and their translations. To evaluate our work, we crawl the dataset from CNN articles. We consider two categories of articles, politics and business. For each of them, we extract 100 sentences randomly. We consider top K accuracy, which is the percentage of reported issues where at least one reported sentence in this top K contains an error. For example, for top 1, that means either the translation of the original sentence or the translation of the top 1 reported sentence contains an error. The result is quite promising. For both software, we can achieve around 70% top 1 accuracy and report 64 erroneous issue and 70 erroneous issue respectively. We can find quite diverse kind of errors. Specifically, we have 5 kinds of errors: under translation, over translation, incorrect modification, word phrase mistranslation, and unclear logic. I will give an example of incorrect modification. For this, if some modifiers modify the wrong element in the sentence, it is an incorrect modification error. For example, here, they remain members of privilege was translated to they remain privileged members. So this is an incorrect modification error. To summarize our work, I firstly introduce what is a translation error and why they are important. Then I introduce why it is challenging to test this kind of software. After that, I introduce our structure-invariant testing framework. And at the end, I present some empirical evaluation results and some examples. Thank you very much, and I'm ready for questions.